I'm glad you came back after page 82. You will notice that these look just a little different. They're still the same tools. I call these scaffolds. They're tools that will help you solve a problem. You will never see me work a math problem without a scaffold. It's just something that has helped me over the years, and I hope it will help you. If you don't need all these things, you don't have to use them, but they help structure your thinking. They help support your thinking so that you can get where you need to go. All right, a 20-foot ladder leans against a wall. So here's my ladder. They tell me that it's 20 feet. And I also can tell us that that's hypotenuse because it's across from the right angle. Making a 60-degree angle with the ground. So they tell me there that theta is 60 and that the ground is my adjacent on this problem. How high does the ladder reach? So they also told us that this is the wall. And they want to know how high up here on the wall the ladder reaches. So that's the number we're looking for. We know hypotenuse is 20. We know theta is 60. We know the ground is the adjacent, but that's irrelevant. We want to know the opposite. We want to know the height of the wall. So we're dealing with H and O on this one. And if you remember SOHCAHTOA, that is the sine ratio. So the sine of 60 degrees is opposite, that's the wall, over hypotenuse, the 20. And then we need some algebra. I'm using the reciprocal of W over 20. I'm using the 1 over 20, flipping it upside down to get 20 over 1. And then I have to do that same thing on this side. Those will cancel. I'm left with W equals, where's my calculator? 20. So the calculator steps will be all clear. 20 times 60 sine equals. So all clear, 20 times 60 sine equals about 17.32 feet. And that makes sense. A wall that high would need a ladder. That's a reasonable answer for this. If it were 1,732 feet, that would not make sense, that I would be climbing a ladder, especially a 20-foot ladder, to reach that height. So always ask yourself if it makes sense. A kite string is 50 feet long. So that means we have a kite right about there with a string that's tailing. And you say, well, Miss Amanda, how do you know that it's tailing? How do you know that this is not the kite string? How do you know that it's this one that's the kite string? And here's how I know. It makes a 40-degree angle with the ground. How high is the kite? So we're looking for the altitude or the height of the kite. Here's your 90, and that helps you figure out all these parts. So the height is the opposite. The hypotenuse is the string, and the ground is the adjacent. And then we need to figure out the ratio that's going to help us. So we know hypotenuse is 50. So I know my ratio has to have an H in it. I'm looking for opposite. So I'm looking for a ratio that has an H and an O. And that has to be so. So you want sine. The sine of theta, which is 40 degrees, the sine of 40 degrees is equal to the opposite, which is the altitude or the height of the kite, over the hypotenuse. And there's your formula. So we're going to use the reciprocal of 50. And we're going to put that on both sides, cancel it on this side. So you're left with the height of the kite is, let's plug it in the calculator, all clear, 50 times 40 sine equals 50 times 40 sine equals, and our answer is approximately 32.14 feet. And you might be thinking, how do I know it's feet? Because the string is measured in feet. So we can put that same unit for our height. A ramp has a 15-degree incline. And I should have already told you this, but let me tell you now. These are not to scale. This is not a 15-degree angle. That's way too steep to be 15 degrees. I just wanted to give you some scaffolds that you didn't have to draw every time. So just be aware, I know that's not 15 degrees, but let's just use the picture as a reference. The ramp is 10 feet long. So based on this picture, ramp is hypotenuse. How high does it rise? So I'll just call that rise. That's the question, above the ground. So this time the ground is adjacent, as it very often will be. Not always, but often. And then here is your hypotenuse. This would be opposite. So you are looking at a 10-foot hypotenuse. We're looking to find opposite. We don't care about adjacent on this one, and we know that theta is 15 degrees. So hopefully you're starting to be able to identify which ratio you need. It's going to be so. Sine of 15. O comes before H in the ratio, so opposite, that's the unknown. We're calling that rise. Over hypotenuse. And then we're ready to solve. So the 10s will cancel here. And I'm left with rise being 10, all clear first, 10 times 15 sine equals. So all clear, 10 times 15 sine equals approximately 2.59 feet. That makes sense if you're thinking about a wheelchair ramp or a ramp that is not high off the ground. It's about 2.5 feet tall. That's reasonable for a ramp. If it were 25 feet tall, that would not be as reasonable. And 259 feet would not be reasonable. So always ask yourself, does it make sense? A tree casts a 25-foot shadow when the sun is at a 40-degree angle above the horizon? How tall is the tree? So let's look at, here's hypotenuse, which we don't know. Here is opposite. Remember, it's opposite theta. And then the shadow would be the adjacent to theta. And we are looking for the height of the tree. So we don't know hypotenuse. We know that the shadow is 25 feet. I forgot to put that in there. Use all the information you can on your scaffold picture, and then you can set up your formula. So adjacent is 25 feet. Theta is 40. And opposite is what we don't know. So we are looking for the ratio that groups O and A. We want TOA. Tangent of 40 is equal to opposite, that's our tree, over adjacent, which is 25. So we're going to get rid of the 25 by using the reciprocal. And we are left with T. And then for the calculator, we're going to say all clear. 25 times the tangent of 40 equals 25 times 40 tangent. I've lost tangent. There it is. Okay. Equals approximately 20.98 feet. Is that reasonable for the height of a tree? Absolutely. That's about right. Don't be alarmed if you keep getting decimals. Occasionally, you'll get an answer that will come out evenly, but don't be afraid of those decimals. That's why we needed to make sure that you know how to round decimals.